Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello, future engineers. Here is another video in Engineers in Progress intended for your thinking skills. And I hope that this will help you in your preparations in engineering. My intention of making the solution direct and not so detailed is to train your brains so that every time you encounter statements in algebra, especially in these uniform motion problems, you can easily formulate and recall the principles, especially the formulas for uniform motion. So that's my intention, to train you in a manner that is needed for engineering students. I will not train you in a manner that is very spoon feeding type, although it should start with that, but it's useless if I'll make the solution in a very detailed manner. I want it, I want you to think of the equations put here so that you will be thinking, not just following the solution and the videos. Now, if you want to anticipate the solutions of these problems, you may by pausing the video. Always do it if you really want to solve the problems, especially if you have started with the first part of the video wherein the principles are there. So problem 19, an automobile averaged 45 miles per hour for the first part of a trip and 50 miles per hour for the second part. If the entire trip took 4 hours and covered 195 miles, for how long was the rate 45 miles per hour? So distance, because this is uniform motion, distance equals speed times time. And there are two parts of the trip. One, the average speed is 45 and the other is 50 miles per hour. And we do not know the time it took for the first part of the trip, but the total time is 4 hours, so the time in the second part of the trip would be 4 minus the time in the first part of the trip. So if we denote t as the time covered for the first part of the trip, so distance equals speed times time, so distance equals speed of 1 time 1 plus v2 t2. So v1 is 45, t1 we just call it t. So 195 equals 45 times t plus 50 times quantity 4 minus t, because the total uh, trip took the trip took 4 hours, so the total time travel time is 4. So therefore the travel time for the second part of the trip is 4 minus t. Simplifying, 195 equals negative 5t, 45t minus 50t, then plus 200. So 195 equals negative 5t plus 200. Negative 5t to the left, so 5t equals 200 minus 195, 5. So therefore t equals 1 hour. So it took 1 hour for the first part of the trip. An 85-mile trip to the beach took the Valenzuela family 2 hours. During the second hour, a rainstorm caused them to average 7 miles per hour less than they traveled during the first hour. Find their average rate for the first hour. We will call that V. So same problem, same principle as above. Distance equals V times time. So it is equal to 85 miles distance, and it is average speed or average rate for the first hour, which is V times 1. So V1 T1 plus V2 T2, we will call the average rate for the first hour of the trip as V. Then the average speed or rate for the second hour of the trip would be V minus 7 because of the rainstorm. So 85 equals V times 1 plus quantity V minus 7 times 1 for the second hour. So 85 equals 2V minus 7. So 85 plus 7 is 92 equals 2V. So V is 92 over 2, so 46 miles per hour. That's the average rate for the first hour of the trip. Problem 21, the 1997 Daytona 500-mile race was won by Jeff Gordon, who averaged 148.295 miles per hour. What was Gordon's time? So time is equal to distance over rate. So 500 over 148.295. So we'll just use the calculator here. So it is equal to 500 over 148.295. So the time is 3.372. So it took Gordon 3.372 hours to complete that 500-mile stretch or race. Two cars leave, so problem 22. Two cars leave from the same point at the same time, traveling in opposite directions. One travels 15 miles per hour slower than the other. After 6 hours, they are 630 miles apart. So find the rate of each car. So the travel time of each car is 6 hours because they leave from the same point and at the same time, and the total distance or their distance is 630. So distance equals speed times time. It is equal to distance 1, which is V1 T1 plus V2 T2. So we will call the rate of the first car as V, and the rate of the second car is V minus 15. But the travel time for the two is 6, and the total distance is 630. So 630 equals V times 6, V of the faster car times 6 plus quantity for the slower car, V sub F minus 15, then times 6. Simplifying, 630 equals 12 V sub F minus 90. So that means 720, 630 plus 90, 720 equals 12 VF. So 720 over 12, the rate of the faster car is 60 miles per hour. And the rate of the slower car is 60 minus 15, so 45 miles per hour. Problem 23. Two airplanes traveling in opposite directions leave an airport at the same time. If one plane averages 480 miles per hour and the other averages 520 miles per hour, how long will it take before they are 2,000 miles apart? So this is similar to problem 22. Distance equals speed times time, V1 T1 plus V2 T2, and average rates are given. So the time is the same because they live at the same time. So we'll call that T. So 2000 equals 480 times time plus 520 times time. So 2000 equals 1000 T. So therefore T is 2 hours. So after 2 hours, the two planes will be 2000 miles apart. Problem 24. A woman leaves home in an automobile on a business trip. 20 minutes later, her husband discovers that she left her briefcase behind and decides to overtake her in another car. The husband knows that his wife averages 45 miles per hour and that he averages 60 miles per hour. How long will it be until he overtakes his wife? So we will call the time until he drives his car to catch up with her wife. So distance is the same. Travel time for the husband, we'll call that T, and the travel time of the wife would be T plus 20 minutes, and 20 minutes is 20 over 60 or 1/3 hour. So distance of the wife equals distance of the husband. That's the idea. Then distance of the wife is speed of the wife times travel time of the wife, and for the husband, speed of the husband, travel time of the husband. We'll call the travel time of the husband as T, and that's the question here. How long will it be until he overtakes his wife? So as soon as he drives his car. So it is 45 times quantity T plus 1/3 hour for the wife, or 1/3 plus T. For the husband, 60 times T. Simplifying, 15 plus 15 equals 15T, where 15T is 60T minus 45T. So T is 1 hour. So after 1 hour, the husband, after 1 hour of driving the husband's car, he is able to catch up his wife. 25. 1 hour after a truck has left on an overnight haul, a messenger on a motorcycle leaves from the same starting point to overtake the truck. If the messenger travels at an average rate of 65 miles per hour and overtakes the truck in 4 hours, what is the average rate of the truck? So, distance of the truck is equal to distance of the messenger. They only differ in the travel time. So the travel time of the truck is 1 plus 4 hours, while the travel time of the messenger is just 4 hours. The speed of the truck, let's call it V, the unknown. So V of truck times travel time of the truck equals velocity or speed of the messenger times travel time of the messenger. So V of the truck times 1 plus 4 hours, that's the travel time of the truck, because it was 1 hour after a truck has left on an overnight haul that the messenger leaves the same point, starting point, to overtake the truck. So equals 65 times 4. So this is 5. So 65 divided by 5 times 4. 65 over 5 is 13 times 4, so 52 miles per hour. That's the average rate of the truck, or average speed of the truck. 26. Two friends living 39 miles apart leave their homes at the same time on bicycles and travel towards each other. If one person averages 2 miles per hour more than the other and they meet 1.5 hour, what is each person's average rate of cycling? So their distance would be equal to 39, and that's the sum of their distances. They only have different uh, rates or speeds, but the travel time is the same, 1.5. So distance equals V1 T1 plus V2 T2. The total distance is 39. So 39 equals V of the uh, faster, so times T, or travel time of the faster friend, then V of the slower times travel time of the slower. So the speed of the faster uh, friend is speed of the slower plus 2, because it is mentioned here. Travel time 1.5, then plus V sub S times 1.5. Speed of the slower times 1.5. Simplifying, 39 equals 3 V sub S plus 3. So 39 minus 3 is 36, equals 3 V sub S. V sub S, therefore, the rate of the slower friend is 36 over 3, or 12 miles per hour. Then the speed of the faster friend is plus 2. 12 plus 2 is 14 miles per hour. Problem 27. A sprinter who averaged 30 feet per second completed a race 1 second before another sprinter who averaged 28 feet per second. What was the distance of the race? So they have the same distance. They only differ in the both speed, average speed, and travel time. So the travel time for the slower sprinter, the next one, is travel time of the faster sprinter plus 1. So distance of the faster sprinter is equal to distance of the slower sprinter. Distance equals speed times time. So 30 times t equals 28 times quantity t plus 1. So 2t equals 28, where 2t is 30t minus 28t, and 28 is 28 times 1. So t is 28 over 2. So 14 seconds. So it took the faster sprinter 14 seconds to complete the race. Therefore, the distance of the race is 30 times t. So 30 times 14, and that is equal to 420 feet. Problem 28. In an automobile race, the rate of one car was 120 miles per hour and the rate of another was 105 miles per hour. If the faster can finish the race in 20 minutes before the slower one, what was the distance of the race? So this problem is related to problem 27, and so they have the same uh, equations except for the travel time and speeds. So distance of the faster equals distance of the slower. For the faster, the speed is 120 and the travel time is, we'll call it t. And for the slower, 105 travel time would be t plus 20 minutes, and 20 minutes in hour is 20 over 60, or 1/3 hour. So 120t minus 105t is 15t. 105 times 1/3 is 35. So therefore, t, the time to complete the race for the faster automobile, is equal to 7/3 hour. Therefore, the distance of the race is 120 times 7/3 from here, and it is equal to 280 miles. Then lastly, for this video, problem 29. One runner ran 1,000 yards in the same time that another ran 985 yards. If the average rate of the faster runner was 1/3 foot per second more than the average rate of the slower runner, what was the average rate of each runner? So time is the same, and time is distance over average speed. They have different distances, but what is important in this problem is the time is the same. So time, distance over rate. The average rate of the faster was 1/3 foot per second more than the average rate of the slower one. So if we express the average speed of the faster runner as v of the slower plus 1/3 foot per second, but to be consistent with the unit, the distance is in yards, so we transform 1/3 foot per second to yard per second. Since 1 yard is 3 feet, so that means we have to divide 1/3 by 3, and that is 1/9 yard per second. So the speed of the faster runner was 1/9 yard per second more than the average speed of the slower. So time is distance over speed. Time of the faster equals time of the slower. For the faster, distance is 1,000, and the rate is speed of, or rate of the slower plus 1/9. I already explained why we have to transform 1/3 foot per second to yard per second to be consistent with the numerator, which is in yards, equals 985 over v sub s. So cross multiply 1000 v sub s equals 985 v sub s plus 985 over 9. Then 15 v sub s is 985 over 9. 15 is 1000 v sub s minus 985 v sub s. Then divided by 15, so v sub s in yards per second is 197 over 27 yards per second. Multiply by 3 to express that in feet per second. So v sub s is 197 over 9 feet per second. Then let's transform this answer into mixed fraction. So v sub s is 21 and 8 over 9 feet per second. Then the speed of the faster runner is 21 and 8 over 9 feet per second plus 1/3 foot per second, and that is 22 and 2 over 9 feet per second. So that's it for this video. I hope that you learned something, and you'll have so many batches of problems on uniform motion. There are more problems, more challenging on the next video.